Hello, everyone. Thank you for joining us today. My name is Joglu Sarwar, and we'll be guiding you through how HPLM is used to manage software projects. HPLM, which stands for Application Lifecycle Management, is a comprehensive tool that helps track all aspects of a software project from planning and requirements to testing and deployment. It ensures that teams work together smoothly, stay organized, and maintain high quality throughout the development process. Whether you're managing small tasks or large-scale projects, HP ALM provides the visibility and control needed to meet your goals efficiently. If you look at the interface, you'll notice how it streamlines communication between developers, testers, and project managers, making sure everyone is on the same page. This platform supports test management, defect tracking, and requirements management, crucial elements for delivering a successful software product. So whether you're new to this tool or aiming to optimize your workflow, HP ALM is designed to simplify complex project management tasks. Pause briefly. Now, let's move on to the next slide. Managing the application lifecycle is essential for ensuring that your software products are developed, tested, and deployed efficiently and effectively. It involves overseeing each stage of the application's life, from initial planning and development through testing, release, and maintenance. Tools like HP Quality Center or QC are used to streamline this process by helping manage test cases, track defects, and ensure quality across the project. Using application lifecycle management features, teams can coordinate better, identify issues early, and improve overall productivity. This approach ensures that the application meets its quality standards and business goals, saving time and reducing costs in the long run. Now let's move on to the next slide. ALM is a web-based test management tool that helps manage the entire application lifecycle, from gathering requirements to deployment. It provides clear visibility into the project's progress for every team member, making it easier to stay aligned. By offering detailed traceability from requirements to tests and defects, ALM helps improve the overall quality of the application. It also enables teams to optimize resources by prioritizing testing efforts based on risk levels. Real-time reporting gives a predictable view of progress, so everyone knows where the project stands at any moment. Additionally, ALM incorporates innovative tools like HP Sprinter, which makes manual testing more efficient. All these features work together to ensure better application performance and a smoother development process. Let's move on to the next slide. So to start the ALM system, you need to open the Application Lifecycle Management page. Once there, click on the link for Application Lifecycle Management. You will be prompted to enter your username and password. Make sure to type those in carefully. After that, click on Authenticate to verify your details. Once authenticated, you will need to select your domain and project from the available options. Finally, click on Login to access the system. This process connects you to the ALM environment, where you can manage your software projects, track requirements, tests, and defects. If you need any further assistance, feel free to reach out. Let's move on to the next slide. The Quality Center is a web-based test management system that helps manage all activities within a testing project, from planning to release. It provides a structured framework for testing applications and maintains a comprehensive database of tests, which allows teams to cover all aspects of the application thoroughly. This system simplifies tracking testing progress, organizing test cases, and linking requirements with testing efforts. It supports the entire application lifecycle management process, ensuring better visibility and control throughout, helping teams improve overall application quality. Now let's move on to the next slide. In this slide, we're focusing on developing a comprehensive release cycle management plan within HP ALM. This plan helps ensure that application releases and cycles are carried out efficiently, minimizing delays and errors. The process starts with defining the requirements based on your business needs and testing objectives. From there, you identify the specific test scenarios derived from these requirements and design tests accordingly. Once the tests are designed, you create a subset of tests aimed at achieving particular goals, allowing you to focus your efforts. You then execute these scheduled tests to identify any issues or problems. If the actual results deviate from what was expected, you submit a defect for tracking and resolution. After testing, you analyze the results and prepare a test report, which provides insights into the quality and stability of the application. This structured approach helps maintain control over the release process, ensuring that all aspects are properly managed from planning to resolution. Let's move on to the next slide. Once the testing process begins, the first step is to define a release tree within the releases module. This helps visualize and plan the entire release cycle, ensuring that all aspects are covered systematically. The release management workflow then guides us through different stages, starting from setting the requirements, creating test plans, and organizing test lab activities. As we move forward, it's crucial to keep track of defect identification and analysis, which directly influences the release readiness. This process helps maintain control over schedules, budget, and quality standards. Clear documentation and structured workflows ensure that each release is efficient and meets the project goals. Let's move on to the next slide. The foundation of the release management process is built around the release tree, which allows us to model upcoming releases within a clear hierarchical structure. To start, the project manager defines a release folder and specifies the individual releases, which are essentially groups of changes in one or more applications that will be released together. Once the releases are set, a Q&A manager then defines cycles. These cycles represent sets of development and quality assurance efforts aimed at meeting the release deadlines. Each cycle aligns team efforts toward a common goal, ensuring that testing and development stay synchronized with the release timeline. The release tree helps visualize how these releases and cycles relate to each other, making it easier to manage dependencies in planning. This approach ensures we maintain control and visibility over the entire release process, from planning through execution. Let's move on to the next slide. The Mercury Tours application folder contains release 10.5, which is divided into 4 distinct cycles. These cycles help us organize the development and testing phases within this release. Cycle 1 focuses on introducing new features, while Cycle 2 also emphasizes new functionalities but includes regression testing to ensure existing features stay intact. Cycle 3 is dedicated to testing for sanity, confirming that the critical functions work correctly after changes. Finally, Cycle 4 is the full release where everything comes together for the complete deployment. This structured approach, broken down into these cycles under the release, helps manage the development process efficiently and ensures quality at each stage. Let's move on to the next slide. The QA manager has the ability to assign specific start and end dates to each cycle within a release. This helps in planning and tracking progress more accurately. By setting these dates early, it ensures that everyone involved knows the timeline and can manage their work accordingly. These dates are important for scheduling testing activities and aligning resources. It's a simple way to keep the project on schedule and avoid delays. Once the dates are assigned, it becomes easier to see the overall timeline and make adjustments if needed. Let's move on to the next slide. Once the requirements are defined, the Q&A lead takes the next step by linking these requirements from the requirement module to specific releases and cycles within the project. This means they assign each requirement to the appropriate release and cycle that has been set up earlier in the release tree. By doing this, we establish a clear connection between what needs to be tested and the scheduled time frame for testing, ensuring that the team knows exactly which requirements are targeted for each release and cycle. This alignment helps in planning testing activities, tracking progress, and maintaining organization as we move through the development and testing phases. It's an essential step to keep everything synchronized and efficient. Let's move on to the next slide. Each test set folder from the test lab module is linked to a specific cycle, allowing us to organize and manage testing more effectively. When a test set folder is created or selected, it is assigned to a particular cycle within the release. This linkage ensures that all tests within that folder are associated with the correct cycle and, by extension, the right release. It helps keep track of what testing is happening at each phase of the release cycle, so teams can monitor progress and coverage easily. For example, in the image you can see how the test set for Mercury Tours is assigned to a specific cycle like Cycle 2, New Features. This connection between test sets, cycles, and releases ensures clarity and control throughout the testing process. Let's move on to the next slide. This workflow in the ALM helps organize and manage the testing process effectively. It starts with defining the releases within a hierarchical release tree, which allows you to model upcoming releases and their components clearly. For each release, you can set specific start and end dates, which helps in planning and tracking progress. Once the releases and cycles are established, requirements are linked to these specific cycles and releases, ensuring that all testing efforts align with the targeted development phases. Additionally, test set folders from the test lab module are assigned to each cycle, connecting the actual test cases to the corresponding release timelines. This structured approach creates a comprehensive view of the testing lifecycle, making it easier to monitor progress, maintain consistency, and ensure quality across all stages. Let's move on to the next slide. Once the requirements are clearly defined, the next step is to ensure we perform test coverage. This involves checking how thoroughly the requirements are covered by test cases, making sure all aspects are tested to meet our objectives. We also perform requirement coverage, which confirms that every requirement is mapped to one or more test cases to ensure nothing is left untested. Converting requirements into test cases helps us implement actual testing scenarios that validate the requirements. Uploading the requirements is important for documentation and reference purposes within the system. Defining requirements is a continuous process that involves clarifying and detailing what needs to be achieved. Using a traceability matrix helps us track the relationships between requirements, test cases, and defects, ensuring comprehensive coverage and helping identify gaps quickly. Let's move on to the next slide. Once you click on the New Requirement button, a dialog box will open up where you can create a new requirement. This is an important step because storing all requirements in one place helps keep everything organized. Requirements define what needs to be delivered to the client at the end of a specific release, so it's essential to document them clearly. Usually, business analysts or BAs will store all these requirements here to keep track of what has been planned and what needs to be worked on. Properly creating and storing requirements ensures that the entire team has a clear understanding of what the project aims to achieve. Let's move on to the next slide. To perform a requirement coverage analysis, first navigate to the Requirements module. Then click on the View menu and select Coverage Analysis from the drop-down. This will generate a coverage report that shows how each requirement is being tested. The analysis provides details on test passes, failures, and tests that haven't been executed yet, giving you a clear picture of test coverage. Once the analysis is generated, you can click on each individual coverage status to view more specific details. To see the specific tests related to each requirement, select Show Test Coverage. This step helps you understand which tests are covering which requirements, ensuring nothing is missed. Monitoring this coverage helps keep your testing aligned with project goals and requirements. Let's move on to the next slide. To access the traceability matrix, first go to the View menu at the top and select Traceability Matrix from the list. When you do that, the page for the traceability matrix will open up. Next, click on the Configure Traceability Matrix button to open the configuration dialog. This dialog allows you to set the scope of the matrix, which shows the relationships between requirements and other requirements, or between requirements and tests. It's a helpful way to understand how requirements are linked and to ensure coverage. Once you've configured it to your needs, the matrix displays the extent of these relationships, essentially showing how different parts of your project connect. This is especially useful for verifying that all requirements are adequately tested and mapped. Let's move on to the next slide. To highlight the requirement conversion process, first click on the requirement from the menu, then choose the Convert Test option. You'll need to select an automatic conversion method that best suits your needs. After that, click Next to start the conversion process. The next step involves choosing the destination subject path, which means you need to go to the test plan tree and select the appropriate subject. Once you've selected the target location, finalize the conversion by completing the necessary steps. This process allows testers to convert their assigned requirements directly into test cases within the test plan, helping streamline the workflow. Remember to follow these steps carefully to ensure your requirements are properly converted. Let's move on to the next slide. Now let's look at designing a test plan tree, which helps us organize our testing efforts systematically. This process involves creating detailed test scenarios, breaking them down into specific steps, and using parameters within tests to handle different data inputs or conditions. It's important to identify any dependencies between tests so that the execution order makes sense. Sometimes you'll need to call or reuse existing test cases to keep things efficient. As tests are developed, you'll want to create and review coverage reports that show how well your tests align with the requirements and ensure all aspects are covered. Monitoring the status of your test plans is crucial to track progress and spot issues early. When we get into the test plan and analysis phase, remember that this module serves as a central repository for all test cases, meaning testers, test leads, and managers all actively participate in updating and reviewing it. Its key elements include design test scenarios, define the steps involved, implement parameters, identify dependencies, call or reuse tests, view coverage reports, and monitor ongoing status. This comprehensive approach ensures everyone stays aligned and the testing process remains organized, clear, and efficient. Let's move on to the next slide. To develop a test plan tree, you start by creating a new folder within your testing tool. Navigate to the test section, then select New Folder. When the dialog box appears, provide a descriptive name for the folder to organize your test plan components effectively. This hierarchical structure helps in managing various test scenarios, whether they are based on system functionalities like screens, reports, forms, interfaces, procedures, ad hoc data conversions, or ETL processes. Proper organization at this stage ensures that each segment of your testing process can be easily accessed and maintained. Let's move on to the next slide. Now, let's look at how to define a test scenario, which is a crucial first step before designing the test steps. You can customize your test scenario based on what's outlined in your test plan, so it's flexible to your needs. To do this, start by selecting the relevant requirement folder from the requirement tree. Once you've chosen the folder, click on the New Test option. Using the shortcut CTRL+ makes it quicker. A new window will open up where you'll need to fill in all the necessary information for your test. After entering all the details, simply click OK to save it. This process helps you clearly define what you're testing, which guides the rest of your testing activities. Once the scenario is set, you can proceed with designing specific test steps, understanding the test scope, and mapping out the expected results. This step ensures that your testing is structured and aligned with your overall test plan. Let's move on to the next slide. To select a test scenario from the left panel, start by clicking on the Design Steps tab in the right panel. You'll see a yellow pen icon in the lower left corner. Click on that and a pop-up window titled Design Steps will appear. This is where you can design your individual test steps. Inside this window, you can name your step, add detailed descriptions, and specify the expected results. It's a straightforward process. Input the step details, review the information, and then save or modify as needed. This allows you to build out your test case in an organized way, making it easier to follow during testing. Once you've added your steps, you can review them in the table below and make adjustments if necessary. This method helps ensure all test scenarios are clearly defined and easy to execute. Let's move on to the next slide. When designing test cases, you begin by filling out the steps, descriptions, and expected results. For each step, you specify what needs to be done, provide a brief explanation of the action or process, and note the expected outcome. After entering a step, simply click OK to save it. To add more steps, click on the new step icon and follow the same process. Just repeat what you did before. If there are common steps from other test scenarios, you can upload test cases here using an Excel file, which helps save time and keeps things consistent. It's important to be clear and precise with each step to ensure the testing process runs smoothly and reliably. Now, let me give you an example. Imagine you're testing a login page. You might start by entering the URL in a browser, and the expected result is that the login page appears. From there, you can add subsequent steps like entering credentials or clicking the login button. This organized approach makes your test cases easy to follow and effective. And just a quick note, make sure the slide title accurately reflects the content. So instead of showing an email and Google Voice number, it should simply be titled Designing Test Cases. Okay, let's move on to the next slide. Now, to define a test parameter, start by selecting the test step where you want to use the parameter. Once you've selected the test step, the parameter icon will become active. Click on the icon to open the parameter dialog. In this dialog box, click on New Parameter to create a new one. First, enter a meaningful name for your parameter, something that clearly indicates its purpose, like username or test ID. Next, assign a value to this parameter, which could be a specific string, number, or any data relevant to your test case. After entering the value, click OK to save it. Doing this allows you to reuse the same test step with different data sets by changing the parameter value later. This is especially useful for data-driven testing where you want to quickly run tests with various inputs. Let's move on to the next slide. The Test Lab module plays a crucial role in executing tests after the test plan has been developed. Once you've finalized your test design, the test execution phase begins within this module, where all calls are made from the test plan section. The process flow starts with creating a test set, then scheduling it for execution, followed by running automation tests or manual tests as needed. After the tests are run, the next step involves analyzing the results and generating reports to understand the outcomes. If any issues are identified, defects can be logged directly from this module to track and resolve problems efficiently. The clarity in these steps ensures a smooth transition from test planning to actual testing, making the process organized and manageable. Let's move on to the next slide. Let's walk through creating test sets in the Test Lab module. First, you need to select the Test Lab module. Then click on the Create Folder icon located in the top left corner of the module. Give your folder a meaningful name to organize your test sets effectively. After creating the folder, select it from the list, and then click on the Create Test Set icon to start building your test set. You'll need to enter a name and a brief description for this test set, so be clear about its purpose. Once the test set is created, you'll want to call test cases from the Test Lab. To do that, select your newly created test set from the left panel. Next, go to the Execution Grid tab for that test set. Click the Select Test button, which will open up the test plan tree. From there, select the specific tests you want to include for this cycle and click the Less Than Equal To button to add them to your test set. Following these steps helps organize and prepare your test cases for execution. Now let's move on to the next slide. Once the test build is complete and the test case is approved, you're ready to run your test. There are two options for executing tests. The first one is Run Test Set, which allows you to execute all tests within a specific set at once. The second option is simply Run, which helps you execute only the selected test. To run an entire test set, start by selecting a manual test within the set. Then, click on the icon that initiates execution. A manual runner window will open up. In that window, you'll see options to start the test, such as clicking the Begin Run button. When you do this, another window appears showing the progress and details of the ongoing test. You can watch the test execution in real time, and once completed, the system will display results and status updates. This process makes it straightforward to manage and execute your test cases efficiently. Let's move on to the next slide. During test execution, you have the flexibility to add or edit steps as needed. If a step passes, you simply mark it as passed. If a step fails, you mark it as failed. You can also capture a snapshot of the test result and attach it to the test, which helps provide visual evidence of the outcome. In the actual result column, you should enter the specific result of the test, what actually happened during testing. If you identify a defect, you can log it directly from this panel, making it easy to track issues. Remember to capture the actual results so there's clear documentation of what occurred, along with attaching any relevant snapshots for context. This process makes your testing more accurate and organized. Let's move on to the next slide. Defect management allows us to handle almost any issue that comes up during testing across various modules. When running tests, if the actual results don't match what we expected, we can log a defect directly from the test lab section. Using the defect module, we can add detailed defects with clear steps to reproduce, review them before final submission, and make updates whenever necessary. It also lets us assign each defect to the responsible team member based on the component involved. We can link defects to specific test cases and requirements to keep everything aligned, and set severity or priority levels to indicate how critical each defect is. Filtering and sorting defects help us focus on the most urgent issues, and we can create favorite views for quick access to common defect lists. This process helps streamline defect tracking and ensures every issue is documented and addressed efficiently. Let's move on to the next slide. When creating a new defect, it's important to first understand the defect guidelines, especially regarding severity and priority, so we can properly categorize the issue. To start, go to the defect section by clicking on the defect link from the left panel. Once you're there, find the options on the right panel and click on New Defect. A new window will pop up where you'll need to fill in all the necessary details. Don't forget to attach any relevant screenshots that can help clarify the defect. Be sure to include detailed steps to reproduce the issue so others can follow the process and verify the defect. This ensures clear communication and helps team members understand exactly what the problem is. That covers the process for creating a new defect. Let's move on to the next slide. This slide discusses the ALM report, which allows users to generate various graphs for different modules within the ALM system. For each module, you can choose from different types of graphs depending on the data you want to analyze. The key modules include requirements, test plans, test labs, and defects. Specifically for the requirements module, you can generate 3 types of reports. The requirement summary, which shows how many requirements are currently in the system, the requirement progress, which tracks requirements accumulated over specific periods, and the requirement coverage, which indicates how many requirements are tested and covered by test cases. These graphical reports help in visualizing the progress and coverage of your project's requirements. Previously, we covered creating test sets, running tests, editing test steps, and defect management, including how to log a defect and create a new defect depending on the severity and priority. These actions are connected to the reporting because understanding defect trends and progress helps in project tracking. The ALM reports are a great way to get a visual overview of where you stand with requirements and testing at any point. Let's move on to the next slide. This slide introduces the different types of requirement coverage graphs that are typically used to analyze and report on test project progress. It includes graphs for requirement summaries, test set summaries, defect progress, defect summaries, and defect age. These visualizations help teams understand at a glance how well requirements are covered, the status and distribution of test cases, and the defect trends over time. Many teams prefer generating these reports using SQL queries because it provides flexibility and precision. For example, an SQL query can extract specific test names and IDs from the test plan, which then can be visualized in a graph for better insight. Combining these graphs makes it easier to identify gaps, track defect resolution over time, and assess the overall health of the project. This is especially useful for stakeholders needing quick, data-driven updates on project status. Let's move on to the next slide. This CL query is designed to show the coverage of requirements in relation to their associated tests, defects, and test case statuses. It retrieves key information such as the requirement ID, name and status, along with the test ID, test name, and the current status of the test case. The query also pulls in defect details like defect ID, summary, and status, which are linked to the test cases. The data is gathered through multiple left joins, connecting requirements to tests, test cycles, linked bugs, and defects to give a comprehensive view of how each requirement is being tested and if any issues have been identified. You can specify particular requirement IDs to focus on, and the results are ordered by requirement and test ID for easy navigation. This helps in tracking how thoroughly each requirement is covered and whether there are any unresolved defects related to testing. Let's move on to the next slide. Customization is a key aspect of project management because each project has its own unique processes and requirements. Based on the project plan, we can tailor features and the process flow to match specific needs. For example, in the defect module, a company like ABC Software Development might want to customize the status options. They can add, remove, or modify these options according to their workflow. The drop-down list could include statuses like new, open, deferred, duplicate, will not fix, assigned, in review, in progress, retesting, clarification needed, and clarification provided. This flexibility allows teams to adapt the defect tracking process precisely to their operational standards. Customization like this ensures that defect management stays aligned with the team's existing procedures and enhances overall efficiency. Let's move on to the next slide. Thank you for your questions. If there's anything else you'd like to know or clarify, please feel free to ask. I'm here to help.